Hello friends, hope you are all doing good during this lockdown period and preparing hard for your NEET and JEE examinations. So here I am trying to bring to you the solutions of previous year's NEET JEE examinations for your better preparation. If you have not watched my previous videos, please go watch it. The links are in the description below. My name is Naveen Kumar and you are watching my channel. For today, we have two special things. One is there will be two questions discussed today, and the second is the connection between one of the questions with this year's NEET examinations. So, to know more about that, please do watch it till the end, and if you end up liking it, please like it, subscribe it, and share with all your friends so that it might help you and your friends secure a very good marks and a better future. So without wasting any time, let's get started.
So we look at this particular question. Four particles A, B, C and D with masses m, 2m, 3m, 4m are at the corners of a square. They have accelerations of equal magnitude that we have to note it down with directions are shown in the figure. The acceleration of the center of mass of the particle is, you have to find out the center of mass of the particle. Okay, this question was asked in 2019 April, so in JEE mains. Okay, now if you look at the question, we have given with a square having 4 points marked as A, B, C and D with set terms as mass m kept at the point A, 2m kept at point B, similarly 3m at point C and 4m at point D, so that you just have to find out the center of center of mass of the, or the acceleration of the center of mass, acceleration of the center of mass. Simple thing. This is a question which is basically from +1's topic of system of particles and rotational motion. So here what we are going to do is we just have to apply the short equation. What is that is, if you want to find out the acceleration of the center of mass, which is equal to, you know, the first mass multiply its acceleration, what is its acceleration, plus the second mass with its acceleration, plus third mass with its acceleration, plus the fourth mass with its acceleration, divided by the total mass. That is a simple equation which you just have to know. Without that we will not be able to do that, which is not a very difficult equation. Okay, now let's mark out the attributes. What are this m1, a1? What is this m1? m1 refers to the first mass at the point A, so that we'll mark the point at the point A. At the point A, the mass is m with an acceleration. What is the acceleration? Acceleration is a, which is marked towards the x direction, but which is shown in the negative x direction, so that we can say that the acceleration can be acceleration ai cap, which is the acceleration towards the x direction, but which is in the negative x direction. That is why we can say that it is minus a. Similarly, the point B, we have a mass 2m with its acceleration shown towards the y-axis, so that we can say that its acceleration is towards the y-axis with the unit vector as plus aj. Why plus aj? Why? Because it's moving towards the positive y-axis. Similarly, the point C, what's the mass here? The mass is 3m with its acceleration which is at the towards the x direction, which is acceleration is definitely towards the x direction, that is ai cap plus ai cap. Similarly, the point D, the mass is having a quantity 4m with its acceleration towards the negative y-axis, so that negative y-axis will show you that the acceleration is aj cap with a negative y-axis. So you just have to substitute the acceleration equation, just have to find out the center of mass equation. How will you find out? You just have to substitute its corresponding mass with its acceleration. What is mass? Mass is m with its acceleration as minus ai cap plus the second mass. What is the second mass? The second mass is 2m with its acceleration as aj cap, plus the third mass is 3m with its acceleration as ai cap, plus fourth mass into its acceleration as minus aj cap, divided by the total mass, which is m plus 2m plus 3m plus 4m. Now children, please look at this equation properly. If you write up to this itself, we can short formally write down that the mass which is multiplied with acceleration, which is I cap, which is a unit vector, so that this together becomes a vector. This is again another vector, this is again another vector, this is again another vector. When you're adding vectors together, you have to make sure that the components in the same coordinates adds together, and similarly the components in the same coordinates adds together, in the sense I caps together, j caps together. So that what you do, we just substitute the I caps together, minus am I cap plus 2m a j cap plus 3m a I cap minus 4m a j cap divided by the total mass. What's the total mass? When you add it together, you get 10m. So that which you just have to manipulate it with the equations. These are the i's together. When you add 3ma I cap minus ma I cap, you will get it as 2ma I cap. Similarly, when you go for the j direction, j components, minus 4ma j cap and plus 2ma j cap, what you will add together, you will get as minus 2ma j cap. Wonderful. Divided by 10m. I hope you are following me, right? Keep concentrating here. Yeah, when you look at this, this is a 2, this is actually a 2, this is a 2, m is here, m is here, a is here, a is here. So that what you do is, you can take the common out with 10m at the denominator. Be careful, 10m at the denominator. So that we can do is 2m can be taken outside, giving you ai cap minus aj cap divided by 10m. So if I cancel this 2 and 10, the numerator and denominator, m and m from the numerator and denominator, then we are left with 5 at the denominator, and a can again be taken out common. So that if I write it as a I cap minus j cap divided by 5, this is your right answer. If you look at the options, you will find that among these 4 options, we have a right answer, which is this, which is the D option, which is the right answer. This was a very interesting question. Similarly, a very important and serious interesting question is coming up in the next one. So students, let's go to our next question. Be careful, I got you a surprise. A particle moves in one dimension from rest under the influence of a force that varies with distance traveled by the particle as shown in the figure. Okay, that means we have to note down one thing. It is moving in one dimension and from rest. That means you have to note down that the initial velocity is 0. Okay, now the kinetic energy of the particle after it has the kinetic energy, we have to calculate the kinetic energy of the particle after it has traveled 3 meters is. That means we are given with a graph also. Look at the graph. That's an interesting graph. Force displacement graph. If a force displacement, you are told to calculate the kinetic energy, it's why? Because there is a connection between energy and work. We have already studied that in the chapter called work, energy, power. This is also a question from work, energy, power plus 1 topic. This was also asked in the 2019 JEE main question paper in the month of April. Okay, now let's look at this figure. If you look at this, we have force which is acting on the y-axis and distance which is given in the x-axis, both units in SI units. That is why we don't have to be worried about converting that into any other units. Okay, fine. The forces are given as 1, 2, 3 marked, and the distances are given as 1, 2, 3 marked in the x-axis. So that what you just have to find out is, you have to find out the kinetic energy after it has traveled 3 meters. So that means we are told to find out what is the final kinetic energy at the end of 3 meters, so that we can call that particular kinetic energy at the end of 3 meters as kinetic energy final. Okay, we are told to calculate how much is that. Similarly, if it is starting from rest, what will be its initial kinetic energy? Yes, initial kinetic energy will be 0. Why? Because you know the equation for kinetic energy is half mv square. Yeah, velocity is 0 means the kinetic energy naturally goes to 0. Okay, now here students, please be with me. let's find out what is the final kinetic energy. Before we find out the kinetic energy, we first have to find out what is the work done. And according to the work energy principle, the work done is equal to, what about the connection with the kinetic energy? Yeah, that has to come in your mind. What is that? Change in the kinetic energy. So that I can say that the work done is equal to the final kinetic energy. So that I can write this as final kinetic energy. I can write it as KE final minus KE initial. Yes. Okay, now here the first thing you have to come into your mind is this question, which is very interesting and very simple question. So that we can say that here we can say that this kinetic energy is equal to 0, which is the initial kinetic energy goes to 0. We have to find out the work done, so that you will get the kinetic energy, so that you will get the final kinetic energy is equal to the work done. So now if I look at this particular equation, that's force and displacement figure, how will you calculate the work done? Work done, if the force and displacement is given to you, you know that work done when the force and displacement is given to you is the area under the force displacement curve, or the area under the force displacement graph will give you the work done. You know that, correct? Which is from the 9th standard onwards in work energy theorem in 9th standard NCERT it is there. So that we calculate the area under this. So that once you calculate the area under this, you will get the work done. How will you calculate the area? Look at this areas. There's a force which is going like this, and then it goes like this. So to calculate the area, you have to calculate the area inside this. That means the area inside this part also. So that if I divide that part into two sections, one is the square, and why it's called a square? Why? Because this side is having 2 meter dimension, here 2 Newton force, so that if you want to calculate the area, what do you have to do? You have to find the area of the square, plus the area of this particular top part, which is looking obviously like a trapezium. You know the equation for trapezium, right? Okay, now let's find it out. What is that? What is the equation for area of this work done is equal to, area of the square. What is that? This side multiplied by this side. What is this side? This side is 2. So that you write 2, and then you have to multiply with the other side, which is again 2. We can write it as 2 into 2 plus then half of, for the trapezium we have to move with the area of a trapezium as half of sum of the opposite sides. What are the opposite sides here? Opposite sides are this. I have to specify sum of the two parallel sides which are opposite. Here these are the two parallel sides, which can be written as this is having a value 2, this is having a value 2, and this is having a value 3. So that I can write the sum of the two parallel sides, 2 plus 3, multiplied by the shortest distance between the two parallel sides, which is 3 minus 2, which is 1. So that I can write this substituted as 2 into 2 is 4 plus half of 5 half will be 2.5. that means 4 plus 2.5 will give you 6.5 joule. So according to our previous conclusions, we have said that the work done is equal to the final kinetic energy, since the initial kinetic energy was already 0 in the question. So that the final kinetic energy can be written as 6.5 joule, which is your right answer. We are expecting that. So if I look at the options, we can say that 6.5 joule, this is your right answer. I believe that you understood it. Now there are two questions discussed today. The first is system of particles and rotational motion is a problem from there, and now this is a question from work energy power. Now what is the connection between these two questions with this coming NEET examination? I believe that the second question, which is this question, has some connection. Why? Because if you look at the previous records for 3 to 4 years, you don't find too much of questions, or at least graphical questions, coming from this particular chapter. And I believe strongly that there is every chance that this year there can be a graphical question. So if you have not tried any graphical question from this chapter, then definitely there is a chance that there can be a question coming from this particular chapter for this year's NEET examination. So all the best.
So I hope you like the video. If you have any suggestions, please put the comment below. It will help me, motivate me and encourage me to bring you more videos like this. Until next time,